Good afternoon, everyone, and thank you for logging into this October installment of Ruskin's continuing webinar series that covers Ruskin's high-performance sun control systems. My name is Warren Thomas. I am in our Louver and Architectural Sales Department and will be giving the presentation today. Please feel free to type any questions you may have during the presentation in the proper area on your screen, and I will answer them immediately following the presentation that we are going through today. Now let's get started. To start our presentation, we'll go over kind of our course purpose and objectives. Really, the purpose is to provide an overview of sun control devices, including applications and benefits, in order to design an efficient stationary aluminum sunshade. Our objectives are going to be to understand the benefits of the shading, identify sun control components, the main components, which are 4 of which, specify and detail best exterior sun control device locations for the most efficient shading and usage, understand the finish types best used for these aluminum sunshades, and to know how shading strategies contribute to lead points. When it comes to buildings, shading of any kind, whether it be overhang or vertical fins, can be used to lessen cooling cost. A top cost for a typical office building after space heating, along with lessening cooling costs, sunshades also reduce solar heat gain, reduce peak electricity demand, and control glare, resulting in greater productivity with greater occupant comfort. The most important benefit to shading your building is reducing solar heat gain. This results in huge energy savings of cooling costs if sunshades are placed correctly to shade the window during peak demand hours. Energy costs are reduced overall due to less load on the mechanical equipment that is used to cool the building. The equipment will depreciate slower, making it have a longer lifespan. Other cost savings from shading including the ability to purchase less expensive glazing, or none at all. The owner can purchase glass with little to no tinting to allow the facility user to see outside more clearly. An uninterrupted view also comes from horizontal sunshades that overhang. Since they hang above the window, they have the same effect as a blind without the view obstruction. The picture shown here illustrates that even a modest depth sunshade above a window can use to improve the office or building environment. And those are literally just 12 inches away from the building. So they really do have an impact, even if minimal. This section is going to discuss the different types of orientation offered for a sunshade, the component names, materials used for a sunshade, and the different fabrication styles. There are 3 primary types of exterior control devices: horizontal sunshades, vertical sunshades, and perforated fins. In this section, you will learn the components of each and help choose which to use on your building. Really, when it comes down to it, horizontal sunshade systems are the most typical form for shading. They are the most effective on the south side or the south elevation of the building. They become less effective on the east and west sides of the building and are pretty much not effective at all on the north side of the building. When placed correctly, they lower solar heat gain while allowing full view from the window. Typically, on the north side of the building, as you see, they become more they have more of a function on the south side, east, west, less so, and on the north side, they really are just strictly architectural. Vertical sunshade systems offer a different look and a whole different shading type. Although shading may be more effective with this placement, they may not offer as good of an uninterrupted view like a horizontal system. Some vertical systems are made with similar components to a horizontal system, including outriggers and blades. Fins are typically installed on the sides of windows to allow for shading and an uninterrupted view. Infill options include perforated screen, aluminum sheet, or even blades. Fins are sometimes used in conjunction with horizontal sunshades in order to maximize your shading. Although sunshades are very custom in nature, there are main components that are on most every design. These are your blades, outriggers, fascias, and installation brackets, the four of them. As you will see here in a few minutes, you will be able to understand that we live a battle of standardization of the product versus a seemingly limitless supply of different combinations. We'll go into that a little bit detailed as we go through the process here. The blade type is the core component of the sunshade. It's going to be typically made of extruded aluminum. It plays a large role in how the sunshade will effectively shade the building. Here in this picture, you will see a trellis grill. When choosing a blade, typical profiles include airfoil and louver blades. Consider the blade span and design while choosing a different blade type. The picture shown here, it happens to be the Curacao airport that I worked on personally, showing a combination of an airfoil sunshade with a tapered outrigger and a Bahama shutter to shade the windows. We had to match the supports of the airfoil, which didn't need as many supports, to the supports of the Bahama shutter that you see directly below it. Here is a list of blades and their profiles shown in the picture. Since blades are made out of extruded aluminum, new blade profiles can easily be made by pushing new extrusions. How an extrusion is designed also dictates the maximum blade span or its structural properties. These here, what you see here, are 8 basic profiles, but even with each one, you can have varying sizes and orientation. And that goes into our increasing amount of different options. A slightly different product, but along the same lines there, is offerings can be used a different material than we have been shown up to now. Instead of using perhaps blades, true blades, you use bar material. And some shades have a perforated screen, or what we will call an egg crate grill infill panel. These infill options offer similar shading properties, but with a little bit of a different appearance. Moving away from blades, we come to the second major component of the sunshade. A front or rear fascia can be added to a sunshade design. A front fascia is the leading edge of the sunshade. From far away, it is the main component seen in the sunshade. The rear fascia is located at the building wall and runs the full width of the sunshade if it exists. Fascias can be made of formed or extruded aluminum. They can be used for an extra support, as used with an intermediate outrigger, or to emphasize the line of a sunshade on a building. The information shown in this slide is a list of the fascias and their profiles, again, similarly as the blades, but these are fascias. Since fascias are typically made from an extruded or formed aluminum, new profiles can also be made by pushing new extrusions to form the new profile. Since the fascia spans the entire width of the sunshade, consider design for the most efficient blade spans. For example, on a recent project, the customer in the Arctic asked for a totally new fascia to be produced to give a leading edge profile they wanted to see. It does not exist as a commercially available item, and we will create a new die for it. And then when you look here, there are the 6 basic options here, and like the blades, where there's 8 of them, they could change orientation and size. Add the 8 blade profiles to the 6 fascias, and you have a greatly increased for your total amount of options. The third component of the sunshade are the outriggers. The outriggers are located at the connection to the building that frames the blades and fascia. They are typically a flat plate that cantilevers out, holding the load of the sunshade. They can be made most of any profile, such as tapered or rounded at the end. If there is a fascia, they can typically follow the profile of the front fascia. They are usually fabricated from aluminum flat plate, channel, or rectangular tubes. False outriggers are used when the blade style cannot span the required width between the outriggers. Since the blade needs extra support, a front and rear fascia will be added, and the load will be transferred to the fascias. In the photo on the right, notice the outriggers have a bracket and then connected to the wall. The false outriggers only connect to the front and rear fascia. If structural support in the form of an outrigger is required to support the blades, that will also require you to have a rear fascia. There's no way around that unless it goes into the wall. Here is a list of the outriggers and their profiles. Since outriggers are typically made from aluminum, tube, channel, as well, they can also do new profiles can easily be designed. Thickness may vary based upon the other sunshade components. I will comment again that we had 8 fascias, 6 different blades, and now 8 different outrigger configurations. You can see here that the total number of options are growing in potential amount of configuration. You could have one fascia with the 6 different blades and 8 different, pardon me, not 8, but 6 different outriggers. Mentioning support rods and cables and tubes are an option, and that can be used to complement a sunshade, but we really don't talk about them being their own basic component. They're just, mostly of their time, they're aesthetic. Rods or tubes may have turnbuckles on them to allow for easy installation and field adjustment without sagging. Most of the time, this accessory is architectural in nature and does not need any support in the end. Typically, this is going to be high snow load areas where we actually just look to add in the support rods. Most of the time, they are just architectural. Installation brackets are the 4th major component of sunshades and are used to connect the outrigger to the building. They can be made from aluminum plate or steel, and this sometimes, even though a customer requests aluminum, so the structure will dictate that you have to use steel. Mounting brackets are typically required on a job site prior to the sunshade assemblies in order to close up the building. The brackets will be mounted to a structure component of the building. There are many types of structure that brackets can connect to, including steel, curtain walls, CMU, concrete, and then wood. Stamp calculations performed by a professional engineer are recommended to ensure the sunshade can handle the loads based upon the location and building type. Like the list shown in the previous, there are many ways to install, and here's a list of typical installation brackets. Thickness may vary based upon the other sunshade components. A point of note is the CMU installation due to the connection reactions. It is common and popular construction method, but is viewed in terms of anchoring, as poor. In our Miami-Dade louver application as a similar example, it is referred to as the worst case scenario and is here as well. And I will point out the CMU block in the top middle right there is where it has the 2 benefits of doing the engineering calculations. We had a job where an architect specified them for a school building and only had the CMU. Like we show here, we had a plate on each side and the architect objected to that. So through our calculations that we were able to tell him that we had to make a change because he did not want to see a steel plate on the inside of the 2nd grade class. Aluminum construction takes advantage of many factors. It's lightweight, and since it's extruded, the shape possibilities are almost endless. Extruded means the material is reflective and less corrosive than steel. The material also can qualify for several LEED credits in the quest of building certification levels. See the LEED section later in this presentation. Extrusions are made by pushing aluminum through a die. This allows for precise or complex profiles, including screw bosses, which will allow for mechanically fastening in the construction. Typical extrusion alloys are 6063 T5 and T6. Ruskin will predominantly use T6. Sunshade construction can either be mechanically fastened or welded. Benefits of mechanically fastening sunshades including being able to have easy component replacement in case of any damage. Sunshades that are mechanically fastened will have clean, strong connections with countersunk fasteners at the outrigger. Welding provides a strong connection, however, it is difficult to provide replacement parts and it allows for variation in color when anodized finishes are chosen. Mechanically fastened connections are clean and smooth, where welded connections invite human error with inconsistent sizes, spacing, and splatter. Weld connections also reflect sunlight where they occur, making them highly visible. If a sunshade has an anodized finish, welded connections will also allow for discoloration where the weld occurs, and also with different aluminum alloys. This is really particular, the welded is really particular here. We'll go on that later. 25. Moving along from our components, we'll discuss some of the typical finish types that are used on aluminum sunshades. Typically, sunshades will be finished so they are protected against the elements. The most predominant finishes are going to be your PVDF finishes, your powder coating, and anodized finishes. Here, PVDF stands for polyvinylidene fluoride. In architectural PVDF coatings, there is a percentage of fluoropolymer resin included in that finish. The higher the percentage, the more durable the finish with regard to exposure to water, UV rays, atmospheric pollutants. The two option finishes are 50% PVDF and 70% PVDF. Other associations come in the form of AMA specifications, which is the governing body for painted finishes. The ones that you predominantly see in the sunshade world is AMA 2604 and AMA 2605. Our 70% PVDF finish meets the AMA 2605 as a two-coat. AMA 2604 specification requires a minimum of 5-year exposure at a 45-degree angle in South Florida at 27 degrees latitude, and 50% PVDF, which is AMA 2604, also does well. So AMA 2605 specification requires a minimum of 10 years of exposure at a 45-degree angle in the South Florida at a 27-degree latitude. These finishes offer superior protection against the elements and is offered in virtually any color required on the project, predominantly as a color to match. Similar to PVDF finishes is powder coating. However, powder coating does not require solvent, meaning this coating system emits nearly zero VOCs. Applied electrostatically and then cured under heat, it offers good protection against the elements and is up to a 10-year finish warranty. If a custom color is required, powder coating is better for a large job because the process to manufacture powder is more difficult than mixing liquid coatings. And also, they aren't necessarily able to match all colors. There's also minimum buys that you'll have to deal with. Anodizing refers to the electrochemical process used to add a layer of natural oxide to the surface of the metal. The sunshades are dipped in the bath of electrolytic solution and a direct current is applied to create the oxide layer. A few alterations in the process may allow for color to be applied to the aluminum, and then finally sealing the pores properly to allow for the strongest finish. Disadvantages of the anodized finishes including color selections limited to clear and bronze hues, shorter warranty periods, touch-up trouble since it's chemically applied, and color variation will most likely occur if the sunshade uses different aluminum alloy types. That last sentence is very important when using sunshades and anodize. When you have your 4 major components, we said your insulation bracket could be aluminum or steel. Your outrigger, your blade, and your fascia could all be aluminum but be different alloys. When submerged and anodized, they could come up with color variation. Moving away from finishes, we will now discuss the best practices for sunshade placement and orientation for using the sun's angles to your benefit. Sunshade placement should be designed in the initial design phase of a project due to the effects on the HVAC system loads. If the sunshade is placed correctly, it will lower peak demand and modify equipment use. There are many tools offered to help find the best spot to place a sunshade for the desired effect. Listed below are the key elements required to find the best placement of a sunshade. Its geographic location, the solar altitude, and orientation. Geographic location is a key element in your shading. However, it is something that you really can't affect. If you require a building in Kansas City, you really can't put it up in St. Louis, right? We will not really discuss this point. However, after you know the geographical location of the project, the next step is finding the proper placement for a sunshade to find the solar altitude, the angle of the sun on the building, for the peak heating season and the swap season. These can be found on websites such as www.suzdesign.com after entering the location of the project and the time of the year. Also note the solar azimuth, the horizontal angle between the sun and the true north. The solar altitude, angle of the sun, is higher during the summer months and lower during the winter months. This is how we can block the sun during peak cooling times and allow for the sun into the window to help heat during the winter months. Once the solar altitude has been found, coordinating the sunshades with the orientation is the next step. Out of all the elevations, again, the south elevation is exposed to the most sun. Horizontal sunshades function very well on this elevation. The calculation of the sunshade is pretty much simple math based upon the geographic location and solar altitude results. To design a sunshade for the south elevation, this is simply as step 1. Draw a section view of the window and draw an altitude line for peak heating season from the top of the window. Step 2 is to draw a solar altitude line from the swap season from the bottom of the window. The intersection is where the bottom edge of the sunshade goes. Here's what sunshades will look like throughout the year. This shows you don't need the moving parts to have a truly efficient sunshade. The pictures show that you can have the sun allowed in your building during the cold days of the winter, you see in the January part of the slide, and have it shaded in the summer with the effective sunshades, where you have your September and you have your March as being your swap seasons. To assist in the process of design, there are modeling programs to assist in design for the previously mentioned inputs. There are 3D modeling programs such as Revit, SketchUp, and ArchiCAD. Help with sun pattern visualization. Manufacturers create ready-made sunshade models for programs such as Revit in order to incorporate into your project. These models can be found online on manufacturers' websites or in industry websites such as Autodesk Seek. Moving on to something away from the product is that we'll discuss the important but basic engineering and considerations to show before starting your sunshade design. To ensure a sunshade is supported for the building and location requirements, wind load plays a large role, and also snow load. Wind load is measured in pounds per square foot, or PSF. The lowest wind load a sunshade is designed is typically about 30 PSF, with higher wind loads around 60 PSF. Wind load affects blade spans. For example, a blade may be able to span 120 inches with 30 PSF wind load, but only 80 inches with 60 PSF wind load. That's where you have to start using your false outriggers. Be sure to know your wind loads and span requirements. When working with wind load, you have these basic requirements. You'll have to have your wind velocity, that's your miles per hour. There's not a direct correlation to wind miles per hour just with a conversion. We do get that question. You will need your exposure category, A, B, C, or D. Its importance factor, 1.0 or 1.15. 1.0 is for standard buildings, 1.15 are key buildings such as hospitals. And then the location of the sunshade on the building. The exposure category explains the terrain around the job site. For example, ASCE 7 describes exposure category B as urban and suburban areas, wooded areas, or other terrain with numerous closely spaced obstructions having the size of single-family dwellings or larger. As the obstructions become sparser or less prevalent, the exposure category moves to C or D. And again, the importance factor 1.15 needs to be applied to facilities that are critical for life safety. These, of course, could be your schools, fire stations, and facilities that house hazardous material, police stations, and prisons. Depending on the location of the sunshade, there may be other loads that need to be taken into account. For example, on these Midwest sunshades, snow load is applicable. This may be a factor in choosing your blade style to account for extra weight and force on the sunshades. Those of you who are pretty sharp and can recognize that as the front of Ruskin manufacturing, you can see that snow on top of our sunshades. We average, 11 to 14 inches of snow a year, and that's obviously more than 14 inches. You look at Buffalo, New York, as one of our worst areas for snow loads, and that could be up to 100 PSF snow loads. Although there are multitudes of blades to choose from due to the ease of creating aluminum extrusion, some are much stronger than others. The strongest blades can span up to 120 inches unsupported at 30 PSF. Those are large airfoil blades and rectangular tube blades. Spans higher than 120 inches are not recommended due to shipping sizes and weights. As mentioned before, if the blade cannot span the required width between the outriggers, intermediate or false outriggers may be added. Adding intermediate outriggers will add lines perpendicular to the blade, so aesthetics should be considered when whether to switch to a different blade that can span the required width or add lines. Next, we'll be going over lead credits for sunshades and shading. Right here we have pretty much the main things that we cover. Sunshades can contribute to the following lead points: sustainable sites, energy and atmosphere, materials and resources, indoor environment quality, and innovation in design processes. The sustainable sites is going to be credit 7.1, and this attempts to reduce the placement of black asphalt and other constructive surfaces that create a heat island effect in urban areas as compared to rural areas with less constructed surfaces. The intention here is to reduce the heat islands. It's to minimize the impact on the microclimate and habitats. What you can do is to implement it, you provide shade to 50% of the site area within 5 years of occupancy, or this credit is achieved to increasing levels of energy performance above the prerequisite baseline and reduce the environmental and economic impacts associated with building energy usage. The demonstration of gains would be to run models with and without sunshades to show your improvement. The materials and resources credit, which is going to be your 4.1 and 4.2, is intended to reduce the impact from extraction and processing of, say, virgin materials and increase the use of recycled content. Implementing this would be to use aluminum with high volumes or high amounts of post and pre-consumer recycled material. This credit is intended to increase the demand for building materials that are extracted and manufactured within the region. You will need to find out where the sunshades are manufactured versus where the project is. This is the main part of sustainability in a building regarding our sunshades, and is the main question that I receive from customers and reps alike in regards to sunshades. What is your recycled content? The intent of indoor environmental quality credit 7.1 or of 8.1 and 8, or anyway, is to provide a comfortable thermal environment supporting productivity and well-being of buildings occupants. To implement this, you will need to coordinate impact of shading in all HVAC systems. I think of this credit as really kind of terms of how well do all the systems in total work together, much in a plus B plus C equals D manner. Credit 8.1 is intended to connect the indoor and outdoor spaces by introducing daylight and views. The credit 8.2 is intended to connect the indoor and outdoor spaces by introducing daylight and views. So, the implementation of these tasks would be to show a model with sunshade providing glare control and show a model with direct line of sight outdoors for its occupants. Really what this boils down to is the 8.1 and 8.2 credit is basically broken down to is everybody happy? The innovation and design credit is to provide design teams and projects opportunities for extra credit points or exceptional performance points for going above the requirements set by the United States Green Building Council. This section is going to talk about how to choose a sunshade that will fit your budget. Obviously, we're going to be talking about in just generalities, but we'll compare blaze styles and talk about what drives up the prices on a sunshade. This section is going to talk about how to choose a sunshade that will fit your budget. We will compare blaze styles and talk about what and sunshade may fall into when comparing side by side. The louver blade styles are typically the least expensive, and the A-crate are typically the most expensive. So the louver blade at the top are your least, and your A-crate is the most at the bottom. This shows the angle flat blade style in the middle because it is taking into account the supports that will be required with that weak of a blade. Since outriggers will have to be spaced so close together, the sunshade is going to be more expensive due to the adding of material costs. Prices can change drastically with additional requirements such as intermediate outriggers, where they're not necessarily needed due to structural requirements, and if front and rear fascias are also required. It may turn out that an airfoil blade is less expensive than a louver blade because it can span the entire width of 120 inches, where the louver blade is needing a support every 48. In summary here, when integrated into a building design, sunshades add many benefits to a project, most importantly, lowering solar heat gain. Also, sunshade components and orientation can range greatly depending on the appearance and building performance objectives. Again, we had all the different outriggers, all the different blades, all the different fascias, and you also have the different installation styles. So you have gone from just a few selections to having literally hundreds of different options for your products. Sunshades can last longer against the elements when finished with an acceptable aluminum coating, such as a 20-year using our 70% PVDF finish. When designing a sunshade, take into account your blade spans and wind load requirements, and also snow loads. A certain blade type may be required, but after looking at the wind load information, it may be smarter for cost to go with a stronger blade style. And also that using sun control products can lead to numerous United States Green Building Council lead points. Now, I appreciate your time and attention to the presentation today discussing sunshades. At this time, are there any questions that I could help you out with? Please enter into the system. There's a question here asking, how often are steel sunshades used? I will see requirements for steel sunshades, but usually the required, the desired shapes are not usually as prevalent with the steel, and so they end up becoming very basic and being very limited in your exposure. So like the most prevalent is going to be to use like an airfoil aluminum sunshade. It looks like we don't have any more questions. That brings us to the end of today's Ruskin's High Performance Sun Control Systems presentation. Thank you again for your time and attention in today's presentation. This will soon be uploaded to YouTube and you'll be able to review it at your leisure. And again, please tune in for next month's presentation, which will cover life safety products and other subjects. Have a wonderful day. Thank you.